All right, so let's dive into the world of data.
Yeah,
As software engineers, we're always dealing with these massive data sets, right?
absolutely.
And figuring out how to query and analyze that data efficiently
Right,
that can really make or break a project.
for sure.
So today we're doing a deep dive into two really powerful tools,
Okay.
Trino and Spark.
Yeah, two heavy hitters in the data world.
Exactly.
By the end of this, you'll know exactly which one to pick for your needs.
So I've heard Trino described as like a speed demon,
Oh, yeah,
especially for interactive analysis.
for sure.
What gives it that edge?
Well, Trino's architecture is really built for speed from the ground up.
Okay.
It uses in-memory processing
Okay.
and a pipelined execution model.
So it's not just keeping the data in memory.
Right, it's not just about that.
There's more to it.
It uses these highly optimized data structures,
Oh, wow.
like custom hash tables to make aggregations and joins super fast. And those operations are really the bread and butter of interactive queries. And Trino is designed to handle them with very minimal overhead.
So as a software engineer, knowing that Trino can handle these complex queries quickly,
Yeah.
I can build applications that are more responsive
Absolutely.
and provide like real-time insights to users.
Exactly. That's powerful. Now, Spark can also leverage in-memory processing,
Okay.
but its approach is a little different.
Okay. How so?
It tends to operate in more distinct stages.
Okay.
And that can introduce latency, especially when you're waiting for a whole stage to complete
Got it.
before you can even see results.
So for those quick ad hoc queries
Yeah.
where I need answers fast, Trino seems like the clear winner.
Yeah, I'd say so.
But isn't Spark also known for speed,
Yeah.
especially when dealing with massive data sets?
Yes, Spark is incredibly powerful for batch processing,
Okay.
where you're crunching through terabytes or even petabytes of data
Wow.
all in one go.
Okay.
Its ability to distribute those large jobs across a cluster of machines is unmatched.
So if Trino is like a Formula One race car built for speed and agility,
I like that analogy.
Spark is like a heavy-duty truck that can haul enormous loads.
Yeah, that's a good way to put it.
Okay, so that makes sense.
Yeah,
But speed isn't the only thing to consider, right?
right.
What about ease of use?
Absolutely.
As a software engineer, I'm always looking for tools that are intuitive and efficient.
For sure. And this is where Trino really shines,
Okay.
especially for those who are already familiar with SQL.
Okay.
It embraces that standard SQL syntax so you can jump right in.
Right into querying.
Exactly. No need to learn a new language.
That's a huge plus.
Yeah,
SQL is like the lingua franca of data analysis.
it really is.
So being able to leverage that existing knowledge base is so valuable.
For sure.
Does Spark offer that same SQL compatibility?
It does.
Okay.
It has Spark SQL,
Right.
but it can get a little more complex for those advanced use cases.
Oh, okay.
You might find yourself needing to dive into Java or Scala programming
Oh, wow.
to really get the most out of it.
So while Spark SQL is powerful,
Yeah.
it might have like a steeper learning curve for someone coming from just a SQL background.
Yeah, precisely. Trino, on the other hand, keeps things really simple with its focus on that standard SQL.
And that's simplicity
Yeah,
that translates to faster development time
for sure.
and less cognitive overhead,
Uh-huh.
which can be a major advantage for engineers.
Absolutely, especially when you're working on tight deadlines.
Definitely.
All right, so we've got Trino leading the pack in terms of interactive analysis
Mhm.
and SQL simplicity.
Right.
Spark seems to be the champion for that large-scale batch processing.
Okay.
But there's more to the story, right?
Right.
What about things like fault tolerance and data reliability?
Yeah, those are critical considerations when building like robust data systems.
Absolutely. And when it comes to fault tolerance, Spark has a clear advantage.
Yeah.
It's designed to handle failures gracefully
Okay.
without losing any data or progress.
How does it do that?
It achieves this through a mechanism called Resilient Distributed Datasets, or RDDs.
Okay. RDDs.
Yeah, think of them as these immutable distributed collections of data.
Okay.
So if a node in the cluster fails, Spark can reconstruct the lost data from other nodes,
Oh, wow.
ensuring that the job continues without interruption.
So it's like having a built-in safety net
Yeah,
that protects your data and your analysis even when things go wrong.
even when things go wrong.
As an engineer, that kind of reliability is essential.
Especially when you're dealing with those mission-critical data pipelines.
For sure.
And this is particularly important when you're processing very large data sets,
Okay.
where the likelihood of encountering a failure somewhere in the cluster increases.
That makes sense.
So Spark seems to be the more robust option in those scenarios where data loss is simply not an option.
Right.
What about when we need to go beyond just querying data?
Yeah.
Are there other capabilities that might sway the decision one way or the other?
That's a great question, and this is where we start to see Spark's versatility really shine. While Trino is laser-focused on querying,
Right.
Spark offers a wider range of functionalities.
Like a Swiss Army knife for data processing.
So you're saying Spark can do more than just query data?
Yes.
Like, what else can it do?
It can handle machine learning,
Oh, wow.
complex data transformations,
Okay.
graph processing.
All within the same ecosystem.
You got it.
So if I need to build a data pipeline
Yeah.
that involves machine learning or like complex data manipulations,
Right.
Spark might be the better choice.
It's definitely something to consider.
Okay.
Now, while you could theoretically integrate Trino with other tools for these tasks,
Right.
having everything within the same framework can just simplify your development and deployment.
Yeah, that makes sense.
So I think we're starting to see the bigger picture here.
Yeah. Good.
Trino is that speedster
Right.
for interactive analysis and SQL simplicity,
Yeah.
while Spark is that workhorse
Uh-huh.
for large-scale processing fault tolerance and that wider range of functionality.
Exactly. And choosing the right tool isn't just about knowing their capabilities.
Right.
It's about understanding the trade-offs.
Absolutely.
So, for example, Spark's versatility
Yeah.
comes with a trade-off.
It does.
It can be more resource-intensive than Trino, especially when dealing with those smaller interactive queries.
Exactly.
So as an engineer, I need to consider not just the functionality of the tool, but also the impact on my infrastructure and my costs.
Absolutely. Understanding these trade-offs will help you make those informed decisions about which tool is the best fit for your project.
Right, and my budget.
And your budget.
Exactly. This has been super helpful.
Good.
But let's break it down even further.
Okay.
If I'm a software engineer
Yeah.
trying to choose between these two,
Yeah.
what are the key decision points?
Well, first ask yourself, what kind of data are you dealing with?
Okay.
And what are your primary use cases?
Right.
Are you primarily doing interactive analysis
Yeah.
where speed and SQL compatibility are really important? Or are you dealing with these massive data sets that require batch processing fault tolerance
Right.
and potentially machine learning or other complex operations?
So understanding the nature of the data
Yes,
and the specific use cases is the first step.
exactly. Then consider the technical expertise of your team.
Okay.
Is everyone already fluent in SQL?
Right.
Trino might be the easier option to get up and running quickly.
So factor in the team's skills
Ah.
and the learning curve.
Absolutely. And finally, think about your infrastructure and budget.
Okay.
Trino is generally more lightweight and resource efficient,
Okay.
while Spark can require more horsepower, especially for those larger jobs.
So those are the key factors. The nature of the data,
Yep.
the use cases, the team skills,
Mm-hmm.
and the infrastructure considerations.
Precisely. And by carefully considering all these factors, you'll be able to make an informed decision
Right.
that aligns with your project's needs and sets you up for success.
This has been great.
Good. I'm glad.
I'm excited to learn even more.
Me too. And remember, even within these categories, there are nuances to consider,
Okay.
like Spark's ability to handle streaming data
Okay.
makes it a good fit for real-time analytics,
Okay.
even though Trino excels at those interactive queries on static data sets.
That's a good distinction. So it's not just batch versus interactive.
Right.
It's about understanding how each tool handles like that constantly changing data.
Exactly, and that's where understanding the underlying architecture of these tools can be really beneficial.
Okay, let's do.
So let's dig a bit deeper into how Trino achieves its speed.
Okay.
It uses a distributed query engine that parallelizes queries across multiple nodes,
Okay.
meaning different parts of a query can be executed simultaneously,
Okay.
which dramatically reduces that overall query time.
So it's not just in-memory processing.
Right.
It's also about how Trino distributes the workload
Exactly.
efficiently across that cluster.
Yeah, as a software engineer, that kind of parallel processing is something you deal with all the time.
Yeah, all the time.
And Trino's architecture is designed to take full advantage of that.
So Spark also uses parallel processing, right?
It does.
But it goes about it in a different way.
A little different.
How so?
Well, it relies on this concept called resilient distributed data sets, or RDDs.
RDDs.
Yeah, we touched on these a little bit earlier when we were talking about fault tolerance,
Right.
but they're also fundamental to how Spark processes data in general.
Remind me, how do RDDs work?
Sure, so RDDs are these immutable distributed collections of data.
Right.
When you perform an operation on an RDD,
Yeah.
Spark creates a new RDD that represents the result of that operation.
Okay.
So this lineage-based approach allows Spark to track dependencies between those different RDDs,
Okay.
which is crucial for both fault tolerance and efficient execution.
So if a node fails, Spark can trace back through that lineage of an RDD and reconstruct that lost data.
Exactly.
But how does this relate to parallel processing?
Well, each RDD can be partitioned across the cluster,
Okay.
allowing different partitions to be processed in parallel. Spark then uses a directed acyclic graph, or DAG, to represent the workflow of operations on those RDDs.
Okay.
And this DAG is optimized to minimize data shuffling between nodes,
Okay.
further enhancing that performance.
So both Trino and Spark utilize parallel processing,
They do.
but they do it in different ways.
Right. Trino distributes queries directly across those nodes,
Okay.
while Spark relies on RDDs and DAGs to kind of orchestrate the whole workflow.
Okay, so those architectural differences
Yeah.
have implications for how each tool performs in different situations.
Absolutely.
So give me an example.
For example, Trino's direct query execution model
Okay.
can be very efficient for those ad hoc queries where you need a really quick answer.
Right.
But for those more complex workflows involving multiple stages and data transformations,
Right.
Spark's DAG-based approach can be more advantageous.
So it's not just about the raw speed of each tool.
Right.
It's about understanding how their architectures align with the types of queries and workflows you're dealing with.
Precisely. And this is where having that deeper understanding of these architectural nuances can be so beneficial.
For sure.
It allows you to make those more informed decisions about which tool is the best fit.
Yeah, okay, so we've talked about speed architecture, fault tolerance, SQL compatibility. What about data formats?
Right.
The way data is stored can have a huge impact on performance.
Absolutely, it can.
Do Trino and Spark have preferences when it comes to data formats?
They do. Trino is particularly well suited for working with columnar data formats like Parquet and ORC.
But
These formats store data by columns rather than by rows,
okay.
which can significantly speed up those queries that only require a subset of the columns.
So if I'm working with a large data set and only need to query a few specific columns, using a columnar format like Parquet with Trino could lead to significant performance gains.
Absolutely. And Trino is optimized to take full advantage of these formats.
Okay.
It can push down predicates and projections into that data source,
Okay.
further reducing the amount of data that actually needs to be read and processed.
So it's not just about reading less data.
Right.
It's also about pushing those operations closer to the source.
Exactly. It's a key optimization technique that can dramatically improve query performance.
And Spark can also work with columnar formats.
It can, but its architecture isn't as inherently aligned with this approach.
Okay.
It tends to perform better with those row-based formats like CSV or JSON,
Okay.
especially when those queries involve those complex transformations or operations that require accessing multiple columns.
So choosing the right data format can have a significant impact on performance.
It really can.
And the best choice depends on the tool and the types of queries you're running.
For sure, as a software engineer, that's valuable information.
Yeah.
When you're designing data pipelines and choosing those storage formats,
Absolutely.
understanding those nuances can make a huge difference in the efficiency and scalability of your data systems.
We've covered a lot.
Yeah.
Speed architecture, fault tolerance, SQL compatibility, data formats. We even touched on streaming data.
Yeah.
But before we wrap up, I want to circle back to a point you made earlier about Spark's versatility.
Okay, sure.
You mentioned it can handle tasks like machine learning
It can.
and graph processing. Can you expand on that a bit?
Of course. So Spark offers a rich ecosystem of libraries and APIs for these various data processing tasks
Okay.
beyond just querying.
Beyond just querying.
One of the most popular use cases is machine learning.
Okay.
It provides libraries like MLlib,
Okay.
which include a wide range of algorithms for classification regression clustering.
Wow.
You can train and deploy machine learning models directly within Spark,
Oh.
leveraging those distributed processing capabilities to
Whoa.
handle those massive data sets.
So if I'm building a machine learning pipeline, I can use Spark to handle everything,
Pretty much.
from data preparation to model training to deployment.
Exactly. And because Spark is already designed to handle those large data sets and distributed processing, it's really well suited for the scale and complexity of many machine learning workloads.
Okay, so that's machine learning.
Yeah.
What about graph processing?
So Spark has a library called GraphX that's specifically designed for graph processing.
Okay, GraphX.
Yeah. It allows you to represent your data as a graph,
Okay.
with nodes representing entities and edges representing relationships between those entities.
Okay.
This can be useful for a wide range of applications.
Such as?
Such as social network analysis.
Okay.
Recommendation systems, fraud detection.
So if I need to analyze relationships within my data, like identifying influential users in a social network?
Yeah.
Or detecting patterns of fraudulent transactions?
Right. Spark's GraphX library can provide those tools and algorithms you need.
And again, Spark's ability to handle large data sets and distributed processing makes it well suited for that.
Exactly.
This is great information. But as a software engineer, I'm always thinking about the practical implications.
Right.
What are some real-world examples of how Trino and Spark are being used?
Excellent question. Let's start with Trino.
Okay.
It's widely used for interactive data exploration and ad hoc analysis.
Okay.
Companies like Facebook, Netflix, and LinkedIn.
Wow, big names.
Yeah, they rely on Trino to query massive data sets and gain insights quickly.
Okay.
For example, Facebook uses Trino to power its internal analytics platform.
Wow.
Allowing analysts to query petabytes of data in seconds.
So for those use cases where speed and interactive querying are key, Trino is a proven solution.
It is.
At scale.
At scale? Now let's talk about Spark.
Okay.
It's used across a wide range of industries for tasks like batch processing, machine learning, and real-time analytics.
Okay.
Companies like Uber, Airbnb, and Pinterest.
Wow, more big names.
Yeah, they rely on Spark to power their data-driven applications.
Give me an example.
For instance, Uber uses Spark for things like ride pricing fraud detection and ETA prediction.
Wow.
Airbnb uses Spark to power its search and recommendation engines. And Pinterest uses Spark for image classification and content personalization.
So Spark's versatility and ability to handle that wide range of data processing tasks makes it a really valuable tool.
It does.
For many different types of businesses.
Precisely. And these are just a few examples. Both Trino and Spark have thriving communities.
That's awesome.
Yeah, and they're constantly evolving to meet the growing demands of the data-driven world.
This has been a really insightful deep dive, but I know our listeners are probably thinking, okay, great.
Yeah.
I understand the strengths and weaknesses, but how do I actually choose the right one for my needs?
Right.
Is there like a decision-making framework I can use?
There is, and it starts with asking yourself a few key questions.
Okay, hit me.
First, what are your primary use cases?
Okay.
Are you focused on interactive analysis, batch processing, machine learning, graph processing?
Okay.
Or something else entirely?
Right.
Second, what are your performance requirements?
Okay.
How quickly do you need those answers?
Right.
And how much latency can you tolerate?
Makes sense.
Third, what kind of data are you dealing with?
Okay. Is it structured, semi-structured, unstructured?
Okay.
How large is the data set?
Okay.
And how is it stored?
So understanding the use cases, performance requirements, and the nature of the data is crucial.
It is. What else should you consider?
What else?
Think about the technical expertise of your team.
Okay.
Are they comfortable with SQL, Java, Scala?
Right.
Or other programming languages?
Makes sense.
And finally, consider your infrastructure and budget.
Okay.
How much computing power and storage do you have available?
Right.
How much are you willing to spend?
So it's a combination of factors, use cases, performance data team skills, and infrastructure. Exactly. And by carefully considering all of those factors, you can narrow down your choices and select the tool that's the best fit for your needs.
This has been incredibly helpful.
I'm glad.
But I have one final question.
Okay.
As a software engineer, I'm always thinking about the future.
Right.
What trends do you see emerging in data processing? And how do you think Trino and Spark will evolve to meet those challenges?
That's a great question, and one that I think about a lot. One trend I see is the increasing adoption of cloud-based data platforms.
Okay, good cloud.
Yeah, both Trino and Spark are well positioned to leverage the scalability and elasticity of the cloud.
Right.
We're already seeing them integrated with cloud services like AWS S3, Azure Data Lake Storage, and Google Cloud Storage.
So the cloud is going to play a major role in the evolution of these tools.
Absolutely. What other trends are you seeing?
What else?
Another trend is the growing need for real-time data processing.
Okay.
As businesses become more data-driven, they need to be able to analyze data in real time to make faster, more informed decisions.
For sure.
Both Trino and Spark are evolving to meet this demand.
How so?
Trino is adding features for continuous query processing.
Okay.
And Spark is enhancing its streaming capabilities.
So real-time data processing is going to be a key focus for both tools.
Yeah. Anything else?
Anything else?
One more trend I see is the rise of artificial intelligence and machine learning.
AI.
As AI becomes more pervasive, we're going to need tools that can handle the scale and complexity of those AI workloads.
Right.
Spark is already a popular choice for machine learning,
Yeah.
and I expect it'll continue to evolve to meet the growing demands of this field.
Oh, okay. So we've talked about the individual strengths of Trino and Spark.
Right.
But how do those differences play out, like, in the real world?
So think about a scenario where a company is trying to understand user behavior on their website in real time.
Okay.
They need to track things like page views, clicks, conversions,
Okay.
and they need to be able to analyze that data like as it's coming in to make those quick decisions about website optimization.
This is like a job for Trino,
Exactly.
with its speed and efficiency for interactive queries.
In this case, Trino could be used to query that stream of user activity data directly,
Correct.
allowing the company to build dashboards and alerts that provide those real-time insights.
And to user behavior.
Exactly. They could identify those popular pages, track conversion rates,
Okay.
and even personalize content on the fly.
So the low latency of Trino's queries is crucial.
It's very crucial because it allows the company to act on those insights quickly.
Okay, so Trino helps them understand what's happening right now.
Right.
But what if
Yeah.
they want to analyze historical data
Yeah.
to identify those long-term trends and patterns?
That's where Spark might be a better choice.
Okay.
Imagine that same company wants to build like a recommendation engine
Okay.
based on user browsing history.
Yeah.
They need to analyze like vast amounts of historical data
Right.
to identify patterns and relationships between users and products.
That sounds like a machine learning use case.
It is a classic machine learning use case.
Spark can handle that, right?
Absolutely. Spark's MLlib library would be perfect for this.
Okay.
They could use Spark to process and analyze the historical data,
Right.
train that recommendation model,
Okay.
and then deploy that model to provide those personalized recommendations.
So they might even use both.
They could.
Trino and Spark.
Yeah.
Trino for real-time insights.
Huh?
And Spark for that heavier lifting of machine learning
Right.
and large-scale analysis.
Exactly. And that's becoming more and more common these days.
Okay.
Companies are realizing that the best approach is often to use a combination of tools,
Right.
each one optimized for that specific task.
It's about choosing the right tool for the right job.
Precisely.
Okay.
And as software engineers, it's our job to understand the strengths and weaknesses of each tool.
Right. So we can make those informed decisions.
Exactly. This has been a really insightful deep dive
It has been.
into the world of Trino and Spark.
We've covered a lot. Their architectures, their strengths and weaknesses, their real-world use cases.
Yeah, we even talked about what the future might hold.
We did as we wrap up.
Mm-hmm.
I want to leave our listeners with one final thought.
Okay.
The data landscape is constantly evolving.
It is.
New tools and technologies are emerging all the time.
All the time.
But the fundamental principles we discussed today, understanding your data, choosing the right tools for the job,
Right.
constantly learning and adapting those will always be relevant.
Couldn't agree more.
So keep exploring, keep experimenting, and keep pushing the boundaries of what's possible with data.
Well said. And remember, the power of data lies not just in collecting it,
Right.
but in understanding it and using it to make better decisions.
Thanks for joining us on this deep dive.
It was my pleasure.
We'll see you next time.